the right-hand rule, but have to be reminded of it. So when we calculate moment, we have two ways. One is using the right-hand rule, and one is solving for it vectorially. We're going to wait on this. We're going to do this first. So we have a force applied, and here's a distance. Here's my distance d. Notice the distance and the force are perpendicular. So the moment, this is point O. Here's the notation. The moment, capital M, about point O is equal to the absolute value of the force times the absolute value of the perpendicular distance. This is how we get the magnitude part. So let's say this is 100 pounds and this is 10 feet. So what's the moment equal to? The moment about point O is equal to the absolute value of 100. Why am I saying absolute value? Isn't this a negative force, right? But we always take absolute value. It's the magnitude of the force, 100, times the magnitude of the perpendicular distance, and the answer turns out to be 1,000, and the units is foot-pound. We'll talk about units in a minute. But remember that this only gives me my magnitude. Is a moment, is a torque a vector? Is a moment or a torque a vector?
Yeah.
Do you have to describe what direction you turn it? You turn a bolt to the left or a bolt to the right, don't you have to say whether you're turning it to the left or right? You've heard of lefty-loosey, right? Turn it to the left, it loosens. Turn it to the right, what happens? Tightens. So it really doesn't matter which way you turn it. Direction is important. So how do I find out? So far, that's all I have is the magnitude here. I only have the magnitude. I need to put in the direction. So you use your right-hand rule. Those of you who are righty, sit on your left hand because you don't need it anyway. Right? Those of you who are lefty, you're writing with your left and you're using your right hand. So everybody, right-hand rule. I'm going to show you how I do it. You might do it a little different. It doesn't matter. You can do it your way. Just get the answer right. The fingers go in the direction of the force. These fingers go in the direction of the force. Palm goes towards the point you're finding the moment about. My thumb is pointing in, so is that positive or negative? Negative. So what is the sign convention? If it turns like this, it's positive. If it turns like this, negative, right? We all have that. Math, this is one thing math, physics, and engineering agree on the notation for, the direction. So fingers go in the direction of the force. Palm goes towards the point I'm finding the moment about. I got it negative. So the direction is determined from the right-hand rule. Everybody good? Okay, let's look at some problems. I think what you do, some of you do from physics, is you put your fingers in the direction of R. We're not talking about R right now. Okay? You put your fingers in the direction of force, so we can do that if you want. What you're used to doing it, or some of you do, you put your fingers in the direction of the distance, and you've got to go from the point you're finding the moment about to the force. So fingers go in this direction, and palm goes in the direction that the F is directing at, and you get a negative. But I don't think that's as clear for me. For me, I kind of think about forces first. To me, a force and then distance. Fingers go in the direction of force, palm goes towards the point I'm trying to find the moment about, and I get a negative. Okay, so let's go on number one. So let's go around. Grading you answered before, right? So Enrique? So I want to find the moment about point A. So the notation, this is very important. Capital M sub A. The moment about point A is, here's a force of 100 pounds and here's a distance. So it's the absolute value of the force, which is 100, right?
Yeah.
And what's the perpendicular distance? Remember, it's force times the perpendicular distance.
It'd be 5
5. So it equals 500, and the units are,
inches.
yeah, foot, inches. Okay, let's talk about units.
Foot inches?
Up into the pound.
Oh, sorry. Okay, wait, hang on. Let's do this. Because I didn't teach it, I didn't even get it right. We're talking about force times the distance, right? What are some examples of, what's an example of a force in the English system? Pounds. How about kips? What's a kip? 1,000 pounds, what's a ton? 2,000, what's a distance? Give me an example of distance in English. Feet. Inch. Okay? So, what do we usually use for, in the English system, when we multiply force times distance? Does foot pound sound right? Inch pound? Well, only if it's inch. So, foot pound or inch pound, have you ever heard pound foot? Have you ever heard pound foot? Jabin, you have?
Yeah.
In automotive?
Well, you usually say foot pound, foot pounds, but isn't it
Sometimes you've
really
heard the other.
pound feet, like just pound per foot?
So,
Thinking about it.
pound per foot is different though, right? Pound per foot means pound over foot. We're talking about multiplying. So the standard is like foot, pound. So we put the distance first and then we put the force. But what about in metric? What are some examples? What are some examples of metric forces? Newton, kilonewton. How about distances? Meter,
Centimeters.
millimeter, centimeter is not used as much, but, okay, so metric, Newton meter or meter foot? I'm sorry, Newton meter or meter Newton? Which one of these sounds more comfortable for you? Newton meter. Here, they put the force first and then the distance. I have no idea why there's two different ways, but this is how we're going to do it. So in English, it is accepted to put the distance first. In metric, it's accepted to put the force first. So let's go back to this. We're looking at pounds and inches, and it's English, so it's got to be inch pound.
You wouldn't convert the inches?
No, you don't need to convert. No need to convert if you're given inches. Unless the number gets huge, then convert. Okay, but that's all I did so far is multiply the absolute value of the force times the absolute value of the distance, and I only got the magnitude. I still need to put in the direction, right? So, Eric, fingers go in the direction of force, palm goes towards A. Do you have a positive or a negative?
Positive.
Positives, then put the positive in. You don't have to put a positive, you can leave it blank, of course it's positive. I usually put the positive in because then I remember that I did it. If I don't see a positive or negative in front of a moment, then I think, oh shoot, I forgot to do the direction. Thank you. Okay, Lucas, next one. Now I want to find the moment about B. So what do I multiply? We can leave the absolute value symbols off now. Force is
You do 100 times
100, and what's the distance?
10 inches.
10. So we got 1,000, inch pound again. Positive or negative, figures go in the direction of force, palm goes, what'd you got?
I think it's negative.
Negative. Lucas, fingers go in the direction of force. Palm goes towards the point B that I'm trying to find the moment about, and I get a negative. Leading. We try to find the moment about A. Do this 150-pound force. So it's 150 times, what is the perpendicular distance to A?
I'm a little confused by this one.
Okay, so we're looking at the moment about point A, right?
Mhm.
And this is the force that we're looking at, right?
All the way up there on C.
Yeah, all the way up here. So this is all drawn perpendicular here. So what is the perpendicular distance? Where's the highlights? Let me get a highlighter. You want to pull out a highlighter again for me? So remember, just one color's fine. Remember that a force, it has a magnitude and a direction, so it's going all along here. Can everybody see that up there on the board? So what is the perpendicular distance, Lonnie, between the force and the A?
Is it the 5, then over, and then?
Well,
and
5 is parallel to it, right?
So it's 7.
It's gotta be this. This is the perpendicular distance between it, so it's gotta be 7. Comes out to be 1050. And we do it inches again?
Yeah.
Yeah. Okay, Sam? So I found the magnitude, right? I didn't put the direction in yet. So tell me, is it positive or negative?
Positive?
Positive. Think of it this way. This is where the center, you know what a pinwheel is, right? Those things you blow and they spin. It's a pin in the center. Think of this as the center of the pinwheel. The force is going this way. You know it's going to spin like that, and that is positive. Okay, moment about D. Uriah? So the force is still 150. What's the perpendicular distance?
It's still 7.
Still 7, right. 1050 inch pound. And what is the sign?
See, so force means.
Force, fingers go in the direction of force, palm goes towards the point,
That looks like it's still positive.
still positive.
Wait, can you go?
Yeah, let's do that one. So here is the pinwheel. Here's the center of the pinwheel. I'm applying a force in this direction. It's spinning the pinwheel like that. It's in the positive. Fingers go in the direction of force. So fingers go in the direction of force, but the palm has to go towards the point you're finding the moment about, so it's a positive. Aaron, moment about C.
Would be 150, oh. Do we have a distance between?
Yeah.
You do not.
So,
There's not one.
0. And does it make sense? It does, because this is a force that's concentrated at that point. It cannot create a moment. It could only move it translationally. Okay, next one, Jabin. We're looking at number 3 now. So everybody, let's look at this. So we know, what is the moment equal to? It's the absolute value of the force. Everybody look up here. Absolute value of the force times the absolute value of the perpendicular distance. You look at this picture, it's difficult to find the perpendicular. First thing we're trying to find is the moment about A. It would be difficult for me, since I'm so removed from geometry, to figure out what that perpendicular distance is, right? We would have to spend some time. It's like a puzzle, it's kind of challenging, we like those things, so we'd like to spend 20 minutes trying to find the perpendicular distance, but we're not going to. So what can I do instead? What do we know about forces that are going off at some angle? They have components. So let's break it into components.
Yes.
Fx and Fy. Fy is equal to 100 times the cosine of 60, and Fx is equal to 100 times the cosine of 30. I always forget which is which, the half and the, it must be that, is cosine 60 a half or 0.866?
Cosine 60 is a half.
It's a half? Okay. So that means this is 50 pounds, and this one is 86.6 pounds. Do you have a way of remembering
Draw a triangle.
Yeah.
besides that?
I guess it's just a table like signs, it had the, in high school, there was a table that we had to memorize.
Right.
And it was like sine, 30, 60, like 45 degrees, and it has a half on the sine, the 30 degrees of the sine and a half on the, I don't know, I just see the
Okay,
table in
but
my head.
and that's how I remember things too visually, so. Okay, so now, let's do this. Okay, so, Claire, we're up to you. Moment about A, so first I'm gonna do Fx, so 86.6 times, here's point A. What's the perpendicular distance from Fx to A?
Fy.
The distance.
I'm so sorry.
But you're right, the y distance, what is it?
7.
Right. And then Fy, notice I'm not putting any signs yet. 50 times, what's the perpendicular distance to A? Clara, did that still?
Perpendicular distance to A,
Yes,
5.
5. So everybody look up here. This force Fy goes all the way up, right? So the perpendicular distance is right there. So let's do positive or negative. Jose, I'm gonna have you do that part. So, the 86.6, this Fx, does it create a positive or negative moment about A?
Say that again. 86.
Yeah. The Fx, does it create a positive or negative moment about A? Fingers go in the direction of force, palm goes towards the point,
Positive.
positive. Okay, how about Fy? Fy, fingers go in the direction of the force, palm goes towards it, what do I get? Positive or negative?
Positive.
Positive. And that equals 8562. 856.2, and we're still using inch pound.
And it's the magnitude of all of that.
Yes, I added it all together. 86.6 times 7 plus 50 times 5.
And then big magnitude bars, yeah?
I stopped doing the magnitude bars now. The first problem we did, I said we were doing magnitude, we're doing
But I
magnitude,
mean, they're
but now
there,
we.
you just didn't write it.
Yeah, right, I just didn't write them anymore. Because it's always, we're always dealing with positive values of the force. So let's just go back a minute, everybody look up here. We had this force.
Move
100.
Move it aside.
Thank you. Is that what you're gonna say?
No.
Oh, okay. I have this force here, and I could have just taken the 100 and multiplied by the perpendicular distance, but I did not have it. And I want to think of, okay, what's the least amount of work? The least amount of work is to break that force into components. So then I figured out what moment is created about A due to Fx, and what moment is created about A due to Fy, and I added them together.
My question was, in the calculations, you want us to include units, right?
Not until you have an equal sign at the end and you give me an answer, then you need to give me units.
Okay.
You do not need to put units here, only at the end when you're giving me an answer. Okay, Jason, moment about B now. So I have 86.6 times, here's B over here. What's the perpendicular distance? 7 again, good. And then 50 times, what's the perpendicular distance? Great, 10. Sam, why would you do the signs? So
Positive.
for the 86, does it create a positive or negative moment? Does Fx create a positive or negative moment?
Positive.
Positive. How about Fy? Fy, put my fingers in the direction of force, put my palm towards the point, positive or negative? Negative. And the answer comes out to be 106.2. 106.2 inch-pound. Bless you. Tara Lynn, how about moment about C due to that force?
C?
Yeah, so here's C, and here's the force. 0. 0, because the force goes right through the point and it cannot rotate it. Let's take a look at the homework problems and see, chapter 4. Yeah, 9's fine. 10's fine. 13. 15. 21. Yeah. 30. Okay, remember that, so the homework problem that I assigned is homework 5. You only have to do the right-hand rule so far. So right now, you only know the right-hand rule. Okay? You're still going to have the whole homework due here, but right now you can finish, I'm assigning the right-hand rule part. So again, take one sheet of paper for each problem and do the right-hand rule on the top, and then save it. Let me repeat that. Everybody with me?
Yes.
Yeah.
Okay. I'm assigning homework 5. Each one of these problems, you have to solve it doing the right-hand rule and doing vectors. We so far only covered right-hand rule. So take out a piece of paper, do number